we have to apply a mix of different technologies, including cyber technologies, to begin shaving off our carbon footprint.
Welcome, everyone, to the Industrial Security Podcast. My name's Nate Nelson. I'm here with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions, who's going to introduce the subject and guest of our show today. Andrew, how are you?
I'm very well, thank you, Nate. Our guest today is Leo Simonovich. He is the Vice President and Global Head of Industrial Cyber and Digital Security at Siemens Energy. And our topic is AI in the energy transition. You know, the energy transition is decarbonization, AI and industrial security when we're looking at the energy transition.
Then without further ado, here's your interview with Leo.
Hello, Leo, and welcome to the podcast. Before we get going, can I ask you to say a few words about yourself and about the good work that you're doing at Siemens Energy?
Andrew, it's great to be with you. Thanks so much for the opportunity. At Siemens Energy, I lead the industrial cyber practice. I've spent about 10 years building this business. It's been a wild ride. A lot has changed in the space. And we've innovated, brought awesome products to market. And before that, I was with a large consulting firm, who's Allen Hamilton, where I did cyber risk analytics for large utilities. Siemens Energy has been on a journey. We became a standalone energy technology company covering the energy value chain as a spin-out of larger Siemens. And we're hyper-focused on the energy transition. And at the core of that transition is the need to decarbonize, digitize, and decentralize. And that is all enabled by digital technologies and, of course, getting cybersecurity right. So we as a company have built a practice focused on operational technologies and industrial cyber. And it is a practice that helps our customers get a better handle on their industrial cyber programs, and it helps them get a better understanding of their risk, and helps them ultimately reduce that risk, because it is just too important. If we don't get it right, the consequences for the environment, but also for operations and ability to deliver energy are just too great.
Our topic today is artificial intelligence and, of course, industrial security in the energy transition. Can you start us at the beginning? I mean, everybody vaguely understands the need to decarbonize. What does the energy transition mean to you and to you folks?
For us, as a company, and for me personally, it is an existential challenge. We talk about the need to decarbonize in the abstract. We know that we need to reduce our carbon footprint, but what does that really mean? Well, we have a world out there that's pretty complex. You got a bunch of old stuff that is aging and it's built on fossil generation. You have renewables, and then of course you have the push to electrify everything. And what that means is that we have to apply a mix of different technologies, including cyber technologies, to begin shaving off our carbon footprint. So we work with customers to help them rationalize what they do with their existing fleets and how they can maximize efficiency, how they can install additional capacity that is cleaner, and ultimately innovative technologies like hydrogen that are going to be groundbreaking. It's an all of the above approach that we need to take to go after this problem. And it really requires a partnership between us and our customers.
So that makes sense, sort of in the abstract. Can you give me some examples? What kind of physical technology systems are you folks working with?
Yeah, the way to think about it is by looking at different parts of the energy value chain. So there's oil and gas, there's power generation, and then there's the transport and, of course, distribution of energy, whether it's oil and gas or it's electricity. We play in all the parts of the energy value chain. In upstream, where oil gets taken out of the ground, we need to do a better job of not releasing carbon into the atmosphere. And there, one of the big challenges, of course, is the flaring of gas. The other is what happens with on-site power generation. So our technologies help capture the carbon, also produce on-site generation. So we're not burning diesel fuel, for example. We can install small wind microgrids that can produce energy right there on site. We can combine an offshore platform with wind together, and we do that in the North Sea. In midstream, of course, it's about a more efficient way of transporting, right, and delivering electricity and oil and gas. And there we are delivering next generation compression equipment, and ultimately, energy's got to get to homes. And we have to have a grid that doesn't lose power as that electricity gets transported. So we deliver software, we deliver transformers, and we deliver metering equipment to help our customers utilize their electricity in a more efficient way. So when the sun shines, it's great. And we can deliver electricity straight to homes, and the wind blows. But sometimes the weather doesn't cooperate. So we have capture electricity through storage by applying the latest and greatest battery applications to help capture electricity and use it when it's needed most.
Something that surprised me in Leo's answer, I had assumed that Siemens Energy was all about, the power grid and windmills and solar panels and it is all that. But the examples that he gave here were also in oil and gas. Oil isn't found in convenient locations. It's found generally far away and off the grid. And so you need power out there. So, they're talking about windmills and solar panels and whatnot out in the boonies to support these remote installations, in addition to, all of sort of the expected. So it was broader than I expected.
Our topic is AI and eventually industrial security in the energy transition. Can you talk about AI? I mean, there's, ChatGPT has been all the buzz. I have a ChatGPT account myself. I've been playing with it. Is that what we're talking about when we're talking about AI, or, is AI a bigger picture?
Yeah, you're right. There's just so much hype around AI. For a very short word, there's so much confusion that comes with it. I think for your listeners, they probably know AI as the latest and greatest innovation, which is ChatGPT. We all use it to ask a question. We all use it to plan our dinner menus or to help plan the latest and greatest trip. But the reality is that in industrial contexts, artificial intelligence has been used for some time to do things like help us find the biggest reservoir of oil out there, or to help us deal with the problem that I talked about around kind of weather patterns and anticipating what those look like and optimizing the energy system to store electricity. Those applications of artificial intelligence, which is all about control and dispatch of energy, right, have been around for some time. They've been narrow and very specialized. What's different? Well, with scalability of compute, which is getting cheaper and cheaper, with advances in large language models, we can now drive optimization in that energy system, which is getting more complex. We talked about it being old. We talked about it being new. We talked about it being more complex. We talked about the need for energy increasing, especially in the developing world, right? So that complexity now needs to be optimized so that you, as a consumer, get the best price for your kilowatt hour, and commercial and industrial companies are able to utilize energy when they need it at the best rates. Artificial intelligence can do that now. From a security perspective, AI has a ton of promise. I tell you, I've seen an explosion of companies and capabilities.
All right, and we are the Industrial Security Podcast. Can you connect the dots for us? What are we worried about security-wise if we're using AI to manage demand, to manage power?
From a security perspective, there are two lenses through which we need to look at AI. The first is AI from a business perspective, an operational perspective. What is it doing to deliver electricity? But the other is, how can that AI be manipulated, hacked, and what can the bad guys do to cause damage? In the old world, much of energy production was air-gapped. But increasingly, with the need to digitize and drive better efficiency, better asset management, right? What we have seen is an explosion of connectivity. And some of that connectivity, of course, can be managed smartly with data diodes from companies such as Waterfall, which have an excellent product. But some of it needs to be managed in a very different way. And this is where artificial intelligence comes in. The bad guys are using it to craft malware that is smarter and can cause more damage. They're using it also to get into energy systems, and this is a product of nation states, and make subtle changes. Here's what fundamentally, and this is very important for listeners to hear, here's what fundamentally is different, how the game has changed. Malware used to be all about digital manipulation of networks or endpoints. Now, physical world commands are combined with digital commands. And guess what happens? When you can create a piece of malware that tells a turbine to spin faster, or tells electricity to flow into a different direction, and if you could do that at scale across multiple points in the system, that leads to those safety and catastrophic events that we all have feared. We've seen some of this come out in the news lately with hackers getting into the US grid using the latest and greatest malware, which we have not seen previously before. And I bet a lot of it was crafted using AI.
Imagine that you work in a power plant. You're responsible for a half dozen massive boilers. If a cyber attack makes one of these boilers overpressurize and explode, that explosion will most likely kill you. Which protection from that cyber attack would you prefer? Would you like a mechanical relief valve, one that steam pressure forces open when the pressure gets too high so the steam is released harmlessly? Or would you rather have a longer password on the PLC controlling the boilers? The engineering profession has powerful tools to address physical risk from all causes, including cyber risks. But where is the relief valve in the ISO standard or the Industrial 62443 standard? These engineering tools do not exist in cybersecurity standards. Andrew Ginter's latest book, Engineering Grade OT Security, A Manager's Guide, looks at this topic. You can request your free copy at waterfall-security.com/engineering-grade-OT-security.
Andrew, in theory, I can imagine AI playing an important part in cyber attacks, but the point that Leo's making there, it doesn't necessarily seem contingent on AI that one would make, say, a highly spreadable malware that causes physical consequences.
Yeah, I mean, back in the day, this was 13, 14 years ago, Stuxnet hit. It was the big news. Back then, as far as I know, that kind of code would have been written by hand. And common wisdom back then and even today is that writing that kind of code is very difficult. It takes an expert. In sort of stepping back for a moment in terms of attacking industrial sites, the sort of the common terminology is there's stage 1 attacks and stage 2 attacks. Stage 1 is where you get into the IT network with a phishing attack or with, a fake website or something. AIs like ChatGPT have been described by researchers as a useful tool for generating phishing emails, for generating credible written content to deceive victims. That's stage 1. Stage 2, producing the code that's going to connect to the PLC and create a new firmware for the PLC that bricks the PLC. That's being seen as much harder. And there's research going on in the space. I cannot name names at this point, but I have been talking to people in private who are looking at using AI for stage 2 attacks. And the question they're asking is, bluntly, can a script kiddie, someone who knows almost nothing but knows how to use AI, can a script kiddie produce, let's say, Stuxnet, is the question. And thus far, the answer seems to be no. You actually have to know what you're doing. But so that's the good news. The bad news is that the research thus far suggests that if you know what you're doing, AI can speed up the process of creating a credible stage 2 attack enormously. We're talking huge advantages for the adversary here.
It's a tricky thing because on one hand, it just seems so obvious that in the near future, attackers will be able to write that stage 2 malware using AI. But on the other hand, at least from what I'm hearing, and I'm not out in the field every day practicing this stuff, so I can't say, but AI has been 1,000% more useful for cyber defenders thus far. I mean, whether it be antivirus, detection, response, what have you, we've been using AI in a way that attackers just haven't for a while. So the notion that this is some big problem that's awaiting us, sort of, it's the reality versus the theory for me. Am I wrong?
No, there's all sorts of stuff going on. Fundamentally, in the stage 2 world, the question is one of writing code, and there's a huge industry out there in the world for writing good code, writing word processors, writing operating systems, writing web servers. So there's a huge industry focused on producing and optimizing AI that will produce code more efficiently for all of the world's software vendors. Again, I haven't been tracking this, but just to give you sort of one example, a taste of what's possible. I'm aware of, ChatGPT has its limitations. Like I said, I've been using ChatGPT. It makes stuff up. It has limitations, but here's the thing. There's a lot of different AIs in the world. And what we're seeing increasingly is these AIs, in a sense, daisy chained together. Now, again, I haven't done this, so to a degree, I'm making this up. But imagine an AI that's focused on understanding, written documents about, PLC communication protocols and turning them into code. And it produces crappy code. And then you pump that code into an AI that's focused on detecting common programming errors. And then you pump the output of that, into an AI that's focused on using that knowledge to correct the programming errors given the original specifications. And you pump that into an AI that's focused on, it's optimized for packaging code into modules, into downloadable components. And you pump those modules into an AI that's focused on integrating the components into a comprehensive, this is happening. This kind of thing is happening. And these AIs are not static. ChatGPT is not the end. It's the beginning. And so in my estimation, the job of creating stage 2 attacks is getting much easier over time.
So that's scary stuff. I know there's a lot of researchers out there playing with this stuff. And, if the good guys are playing with it, you can be sure the bad guys are playing with it. Can you go a little deeper? What's possible?
Your imagination can run wild. But what we have seen in working with our customers is the use of AI to develop malware that is frankly smarter, more attuned, but that combines different elements of the attack, leading to consequences faster. And what I mean by that is if you can begin to manipulate a particular process or a particular piece of equipment, a valve, a PLC, right? And you can do that using digital commands, right? And you can combine, to your point about kind of using multiple dimensions of attack, combine multiple processes together, then damage can occur at a greater scale and can occur much faster. Believe it or not, it's easy to trip a power plant. It is, and have the turbine shut down. There are a lot of safety mechanisms to manage human error, for example. It's a lot harder to manipulate a turbine or an oil refinery to cause a boom event or a safety event, right? Tricking those safety mechanisms is what AI is really good at. Because it now is able to play the chess game on not just on a kind of a one-dimensional level or two-dimensional level. You can play it on a three-dimensional level, moving multiple pieces all at the same time.
How are we doing on the defensive side? What are we doing about this? What should we be doing about this?
The consequences are real. And unfortunately, we will not only see more and more attacks, but we will see those attacks feature an AI element. And this worries both customers and regulators that I talk to. They recognize that the playing field is changing, that this technology in the industrial context, again, we're not talking about ChatGPT, is accelerating. And because of that, we need to get a better handle on it. So the White House, with its latest AI guidance and its cybersecurity strategy, had specifically called out the dangers of AI when applied to industrial control systems. More broadly, there's recognition for better visibility and better tooling on the defensive side. So the regulators now are saying, you know what, it used to be that cloud in operational context was a dirty word. How can you take operational data out? But if we're going to compete with the bad guys, then we need to have the same levels of compute. And so the regulators are now issuing guidance around cloud and emerging technologies, and specifically the thing that they're calling out. And this is where we, Siemens Energy, have been hyper-focused. They are calling out the need for visibility. This is very important because if you don't have basic visibility and understanding of your environment, then it's very, very hard to know, A, whether you're being attacked, B, going after those attacks at speed, and then C, being able to recover from them. And what we know for a fact is that AI is going to increase the speed of the attacks. And we, on the defensive side, need to increase the speed of our response. We just need to play faster.
If the threat is increasing because of AI, basically we should expect most cyber attacks to become more capable, or expect the high end to become more capable, and sort of everything trickle down. It sounds, I interpret what you said, correct me if I'm wrong, as we need our defenses to become more capable pretty much across the board. And I have heard recently, I think SANS put out in 22, a top 5 security controls for industrial control systems, sort of not here's everything you have to do, but here are the biggest gaps on average. And one of them was incident response. It does no good to detect incidents if you can't respond. It has some value preventing the incidents, but you can't always prevent everything. And so you need a detection capability, you need a response capability, and it's important that we get all this right. We got to fill in the gaps to make our systems more capable. I'm putting words in your mouth, but is that what we're hearing here?
We have chased the capability of detection for some time. Our approach at Siemens Energy has been different. We recognized a long time ago that you need to look both at the physical and the digital worlds together as a unified threat stream, that there needs to be context and smarter and more proportionate response. So our approach has been to get at the context, you need to get at operational data. The challenge, of course, has been that when you have operational data, what to do with it. IT teams are not well prepared to interpret that data, to know what's a threat and what's not a threat, to understand when to take action or recommend action to the plant operators. So being able to translate between the IT world and the operational technology world in a way that helps explain consequences is key. Because shutting down a plant is very, very expensive. And yet the cost of an average industrial cyber attack in the energy sector, can be from anywhere from $1 million to $6 million a day. It's a lot of money. And so we have to somehow play this balancing act between taking proportionate response and taking smarter response that's informed by operational context, right? And getting more speed at being able to detect and recover. So what else? We're talking about AI, Andrew, and what does this all this mean for AI, right? And what it means is that actually AI is really good at finding the needle in the haystack. In our world, we built a platform that does monitoring and detection. It is really good when we have large scale models that help detect that subtle change in the process and correlate it against your net flow data to say we see something is weird. But what to do about it, right? How consequential is it? We have to understand how that particular threat could cascade through the environment, and at a system level, what the impacts could be. So, and this is where AI can have a really important role to play, because we can look at, multiple misfirings, as you may call them, or multiple alerts at different parts of the system, or how quickly something is propagating. So AI can be really powerful in all this context, but taking the right approach that combines the physical and the digital worlds together, right? Using AI smartly is key. And yet, and let me pause in just a second. And yet, we have energy companies, right? They're just getting basic visibility. They're just getting their asset inventories. They're just beginning to pipe data into their SOCs. Whereas the bad guys, right, have built a full stack of malware factories that are AI driven. We have to get faster at becoming more mature around this topic of detection.
So Leo's been talking sort of at a very abstract level here. He's talked about, he's talked about finding a needle in a haystack, and I like that analogy. We have had other guests on talking about anomaly-based intrusion detection, and correlation of alarms, and using AIs in all of that. So we've actually had people on talking about AIs, but using different words. If you have, I don't know, a gigabit per second of network packets in an industrial network that you're watching, there's a haystack. There's, a gazillion packets coming by every second. And the AI is asking the question, are any of these patterns of messages indicative of an attack? And you can do it signature based. You can say, I recognize that message. That message is always an attack, and raise an alarm. Or you can do it anomaly based, which is looking at sort of patterns of messages and saying, this is an unusual pattern. No idea what it is. Raise an alarm. It might be an attack because it's different, because it's unusual. So, this kind of AI has been used forever. The same thing's been used in SEMS, in security information and event management systems, in your security operations centers. They get millions of alerts of, syslog messages, millions of messages per day from 150 of your plants. And again, they're looking at this haystack and saying, do any of these messages add up to an attack? I mean, some of them are obvious. You are under attack, ! Out of one of your intrusion detection systems. But others are, Fred here just logged in from India. He lives in North America. And he logged in 10 minutes ago from North America as well. And you can put together, weirdness like this. So, we've been talking about this for some time now. We've never gone into detail. I would welcome a guest coming on talking about how the AI under the hood of correlation engines and anomaly detection engines actually work. I mean, I've heard words like Bayesian, and I have no idea what they mean. So, I'd love to have people on someday explaining how those AIs work. But, the whole concept of AIs on the defensive side, finding needles in a haystack. Yeah, this has been done for a while, and it's going to get, bigger. There's going to be more of this.
So that's a great introduction. We see the application, we see the problem, we see some hints towards solutions. Let's get specific. I mean, Siemens Energy is active in this space. Can you say a few words? What do you guys have? What do you guys do? What can people call on you for? In this problem area.
Well, we've been on a journey. In our thinking around operational technology, AI has really evolved. A bit of self-reflection. we at Siemens, it was our PLCs that were impacted by Stuxnet. We saw the subtle manipulation of process. That event was a wake-up call for us to get serious about industrial cyber and operational technology. This was a while back, of course, a lot of water under the bridge. Yes, we had to get serious about product security, and we hired almost 2,000 people around the world to support us, product security managers, folks in incident response, folks that deal with vulnerabilities. And guess what? The world around us at the same time was changing, and it's changed a lot. It's become more digital, as we've talked about. It's become more interconnected. We've become more dependent on our customers. And we recognized that it wasn't just about securing the box. What we needed to do was secure the operating environment, the whole operating environment, whether it was our stuff or somebody else's stuff. The customer just needed help. And they were figuring things out at the same time as we were. We just had a little bit of a head start. So we developed a practice in industrial cybersecurity focused on this problem of visibility that I've talked to you about. We recognize that going after the visibility problem from a technology perspective doesn't necessarily make us safer, because everybody talks about their latest and greatest silver bullet or their best detection box. What we saw is that there was also a human capital challenge in this space, that there were not enough folks cross-trained in control systems, in networking, in security, and now increasingly in data science. Those folks are still very rare. So what we've done is we've built a business and a practice in this space. What we offer to customers is fundamentally, we are the trusted advisor. We don't have all the answers, but we'll figure it out together. And we'll be there with you along for the ride, because as digital technologies get introduced, as there's a lot of hype around AI, as the threat landscape changes and the number of attacks increases exponentially, we will be there as we have for 120 years. And so we've built a consulting practice, a managed service practice. We built some proprietary technology around detection. But ultimately what we do is we build bridges between IT teams and OT teams to work with one another, because it is going to take that interdisciplinary approach. And we hope to be in the center of it, helping our customers.
We've talked about the problem. We've talked about some solutions. If we're starting at zero, I mean, we've got an energy customer. Do these customers know how much AI they're using? Do they know how much AI is coming after them? Do they know how much trouble they're in from both ends of it? And, whether they know it or not, sort of, what are the first steps? How do they get started dealing with this new threat?
AI, there's a lot of hype around it. And I think there's general awareness within security teams, both on the IT side and the OT side, that AI holds a lot of promise, but could also be used for very, very bad things. On the OT side in particular, I'd say there's a lot of skepticism. And the reason is because plant operators need to be able to unlock the black box that AI represents. They need to understand it. Maybe it's an engineering approach, and engineers need to kind of understand what's happening. You need to be able to understand the methods. You need to be able to kind of trace the logic. And so when I talk to security folks within plants, they're skeptical of the latest and greatest tools. And they want to know, how do you detect something? What is this Bayesian belief? sounds very fancy, but if I can't even do the basics, why should I go after this problem? So there's both skepticism and desire. And there's one more thing, which is the chief digital officers, chief innovation officers, the boards are telling security teams, you gotta give me use cases around AI, both from a business side and the security side. And I know some customers that need to deliver a use case a week to the board. That's how closely it's being monitored, if you think about that. So sleepy giants that have been doing things the same old way, extracting, pumping oil out of the ground for the last 50 years the same old way, are now being called to innovate in this space. And then there's kind of the middle of the pack, folks that fear they're going to be left behind. And then there's the small guys. And by the way, those represent, if you look at the United States, right, 3,500 utilities. Once you get outside the top 200, everybody's small, kind of mom and pop, community, distribution facilities, power plants. Those folks don't even know how to get started. And to get to your question of how you get started, I think the basic question that one should be asking is, first and foremost, what is important to me? What are the assets that are key that I need to get a handle on? Be able to understand the risk, understand the vulnerability, understand the exposure, monitor it, and then build an AI layer around it. And by the way, those two things are very closely correlated. The assets that are really important to be monitored, assets that could benefit from applications of AI, assets that attract the bad guys, and assets where a security AI use case is really valuable. So the first step is asking what's important. The second step is figuring out what data needs to travel to be able to get a basic context. And then the third step is the step that I call kind of advanced detection, where AI needs to play a role in understanding not just basic characteristics of a particular process or a particular asset, but kind of three-dimensional behavior of production, right? And the manipulation of that to cause that boom event that you and I, Andrew, talked about.
So, Leo, this has been enlightening, a little distressing, but enlightening. Thank you for joining us. Before we let you go, can I ask you to sum up for our listeners? What should we be taking away from all this complicated space?
Well, first of all, it's not all doom and gloom. There's a lot of anxiety around this topic, but it's definitely a journey. There are trusted partners that can help you. Don't get wrapped up in the hype and the chase for the use cases just because the board is asking. Take a more measured approach to get a basic handle of your environment. AI will come. There are steps that you can take, both around the business side, the operational side, and the security side, to measure whether AI can benefit you. It's not a down the line thing, however. Most folks will say, I'm not mature enough, and therefore I should not dabble in it. The reality is this technology is getting too good, and the gap between the defenders and the attackers is really widening. And so time is short. So don't wait till you get other aspects of your OT cybersecurity program right. Begin to dip your toes into this space. Start by building some of these detection models. Start by picking assets that are important to you and getting a better understanding of their behavior. And then ultimately look out for the regulation that's coming down the pipe, and work with your suppliers to make sure that you can demonstrate that you're taking smart steps to better prepare yourself for what's going to be an exciting future, and one where I think ultimately the good guys will win.
Andrew, that was your interview with Leo Simonovich. AI is a big topic in cybersecurity everywhere today. Do you have any final thoughts about the subject to close out our episode?
Yeah, I mean, thinking about this, a couple of things. One is that historically, 5 years ago, AI was sort of the anomaly. There was a little AI in the detection algorithms. There was, a little bit of AI sprinkled here and there. Increasingly, AI is everywhere. And, in the industrial space, I think we all need to get used to the thought that AI is our future. What's the number one investment that people make routinely in industrial processes? That engineering teams make routinely. They make investments to make the process more efficient. One of the ways you make processes more efficient is that you make decision-making about the process more efficient, more accurate, more effective, faster. I think AI is essential in that process. AI is going to be essential to all of us to be making our processes more efficient. And this is just on the in a sense, the mechanical side, just, doing things. On the cybersecurity side, the bad guys, I'm sorry, they're investing in making their attacks more efficient as well. And so on the defensive side, we've been doing stuff in sort of intrusion detection for a long time. I think we need to we need to invent ways to use AI to make our defenses more efficient. Everyone is, bad guys and good are using AI to make everything more efficient. I don't think we can ignore this anymore. I think this is, this has to become sort of the common language, the common wisdom of the space going forward. So, I'm grateful to Leo, and I look forward, fortunately or unfortunately, to thinking about AI a lot more in the years ahead.
Yeah, it feels like a topic that we might have more episodes about in the next few years than we have in the past few, even though we have covered it at times. Anyway, thank you to Leo for bringing that up with us. And Andrew, as always, thank you for speaking with me.
It's always a pleasure. Thank you, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody out there listening.